Triangles, the rule of their angles and the rule of their sides. All right, let's start with the angles of a triangle. The sum of the three angles of a triangle is always going to equal 180 degrees. And it doesn't matter what kind of triangle you have. It could be an acute triangle where you have three acute angles. If you add those angles together, it will equal 180 degrees. It could be an obtuse triangle where there's one obtuse angle, two acute angles. You add those angles together, it's still going to be 180 degrees. Or it could even be a right triangle where there's a right angle shown with a little square. The other two angles are going to be acute. You add those three angles together. Of course, the right angle is 90 degrees, and they'll still add up to equal 180 degrees. So with that in mind, we could take a problem like this. With two angles that are given to us, the other angle is called x. Find the value of x. Well, let's use the rule we just learned. The three angles added together would equal 180, so we can set that up as an equation. We can take the two angles whose measures we know, add them together, and then from there we can subtract that value from 180, and we will get the value of x, 32 degrees. Now, what if I had to write an equation that could be used to solve x with a situation like this, where we have an angle up here, 5x, here we have an angle 7x plus 5 degrees, and then down here we have 79 degrees. Again, this can look a little complicated, but the basic idea is still the same. The three angles are going to add together to equal 180 degrees. The first angle is 5x, the second angle is 7x plus 5, the third angle is 79, and it honestly doesn't matter what order you put those angles in, but there you go. There's an equation that we could solve to get the value of x. Now, the rule for sides of a triangle is a completely different situation. This is called the triangle inequality theorem. The sum of the lengths of any two sides is going to be greater than the length of the third side. Let me show you what I mean. Here we have a triangle with sides 9, 45, and 43.5. I can add two of those sides, and it will be greater than the third side. For example, 9 plus 43.5 is it greater than 45? Well, yes, it is, because if I add those two numbers together, I'll get 52.5, which is definitely greater than 45. Let's switch up the order. How about 43.5 plus 45? Is that going to be greater than 9? Well, of course, it's definitely going to be greater than 9, so that one checks out. And then what's the other combination I haven't tried yet? How about 45 plus 9? Is that greater than 43.5? Well, of course it will be. And so all three ways that I could add two sides together and see if it's greater than the measure of the third side, all three ways are going to check out. And this is important because if you have a situation like this, where two sides do not add together to be greater than the third side, then you're going to have a situation like what you pictured here, where these sides cannot actually make a triangle. They wouldn't touch the 9 feet and the 4 feet to actually complete the corner there of that triangle. Let's look at a problem like this. Two sides of a triangle are 32 feet and 54 feet. Which of the following, we have multiple choice here, could be the measure of the third side? All right, if you are thinking that you should add up the 32, the 54, and an unknown angle and set that equal to 180, I got news for you. That's the wrong idea for this problem. It didn't even talk about angles. It talked about sides. And what's the measure of the third side? Not third angle. So this has nothing to do with 180 degrees. This has to do with the triangle inequality theorem, that the sum of the lengths of two sides has to be greater than the length of the other side. So we can use that idea. Starting with the two sides we're given, 32 and 54. We can add them together and say that it's greater than the third side. Well, what is the third side? We don't know. We can call that a variable. Well, we know 32 plus 54 is 86. This means x is going to have to be less than 86 when you flip the entire inequality symbol around. Now, the other way we could set this up is 32 plus x would have to be greater than 54. And then we could subtract 32 from both sides. That's going to tell us that x has to be greater than 22. Now, there is technically a third way of setting this up, 54 plus x greater than 32. But 54 is already greater than 32, so that third way is really not even needed to be set up. So, based on these two results, we can see x has to be less than 86, but it also has to be greater than 22. That means it must be between those two numbers. And there is only one answer choice here that is actually between 22 and 86, and that is the choice of choice A. Choice C, 22 is not greater than 22. Choice D, 86 is not less than 86. So don't be fooled by answer choices like those. It has to be in between.